So, good morning, class. Today is our sixth lecture. In previous class, we were discussing about canonical and standard form, basically main terms and max term. So, we come to know that main terms are formed with the help of binary variables available in complement form or in a normal form with AND operations. Those becomes main terms. However, if these variables available in complement or normal form connected together with OR form or OR operation, then that is called max term. And mid term and max term both are complementary in nature. Thereafter, we come to know that Boolean function can be expressed algebraically from a given truth table by forming a midterms for each combination of the variables that produces a one in the function and then taking the OR of all those terms. In fact, some of you have tried to formulate a problem and then written truth table and then function, and after that you realized. So that was a good attempt to understand how to write midterms, how to write function, how to formulate problems, and how to implement at all. So this was a good exercise. I would request again to all of you, please attempt formulate any problem which are coming to your mind. But uh, this problem statement should be concrete, should be very specific, and uh, minimum confusion should be there. Okay. Now coming to this example where f1 is given as x bar y bar z plus x y bar z bar plus x y z. So we can write also as m1 plus m2 plus m7. And this table tells about how to designate midterms and how to designate max term, corresponding max terms.
Excuse me, sir.
Yes.
Sir, I have a doubt in the previous page, sir.
Okay. Yeah.
Sir, here for the designation, you wrote in the book it's written M2 for X0, Y1, and Z0.
Which one?
Sir,
Can you
for M2.
M2? Okay. Yeah, this
Sir,
one.
sir, if we have like that X0, Y0, and Z1, sir, I mean to say that if someone writes the order in a different manner, then will we have the same designation or different designation?
Same matter means just tell me function I will write here. What
Sir,
function?
so let us say that for the x first we wrote four zeros then four one. For y we wrote two zeros two one two zeros two one alternate manner. Sir, if we write for x two zeros two one two zeros two one and for y first four zeros then next four ones, will we get the same designation?
What are you talking about? I'm not able to tell. First, look at where you are talking out of these eight
Sir,
one.
for M2, M2.
M2 is okay. Yes, M2 is denoted as midterm X bar Y Z bar. Okay, and this is coming from here. This is X bar Y Z bar, and corresponding max term is X plus Y bar plus Z. Why? Because they are complementary in nature. I will take the complement X bar Y Z bar. Take the complement. So it will be x double bar plus, because this dot will convert it into plus. That is the AND operation is converted into OR operation, because max term is the OR of the midterms. Then this will be 1 bar plus z, sorry, z double bar. So it is ultimately what happened? X plus y bar plus z. This is what is written here, x, y bar, z. Here now tell me what is your confusion here.
Sir, let us say that I formulate a truth table like in the first x remains the same, but for y I write 0, 1, 0, 1 like that, sir.
0 1 0 1 means,
Sir, for y we have for m0 we have 0, 0, 0. For m1 we have 0, 0, 1.
see, this has significant. It's not like that. You look here. I think this it is assigning some weight like 2 to power 0, 2 to power 1, 2 to power 2. So it has weight. 2 to power 0 means 1, 2 to power 1 means 2, 2 to power 2 means 4. So Z has least significant, Y has higher, and X has highest. So 4 to 1. If you convert any number like this is what? X has 4, now 1 multiplied by 4 plus 0 multiplied by 2 plus 0 multiplied by 1. So ultimately it is 4. Okay. So then accordingly this 4 is written here. So it has
That
direct
was
relation.
that was what I was asking, sir.
So you mean to say you are telling that order you can write number in any fashion, but its weightage will be same. Okay. Suppose you want to write like number 1, 5, 6, 7, 2, 0 like that. There's no problem as far as logic is concerned. Okay, anything can in order, but it is not convenient way. It is not a traditional way to take care all numbers. So it is better always write to number in order. That is a ascending order. So this number is written in a ascending order so that you can track it. Okay, which number is missing. So it is easy, very easy for me to track any missing number if I will write in order like 0, 1, 2, 3, 4, 5, 6, 7. Suppose 4 is missing. So I'm just counting 0, 1, 2, 3, 5 is coming. It means 4 is missing. However, in this way, if I write in any arbitrary manner, then it will be very difficult to be identify the missing number. Okay. And whatever number
Yes,
is
sir.
whatever number is written, it has some significance. It is not in arbitrary manner. So either like A, B, C. So it means we go canon, we go by convention, and that is convention is that this is the least significant. This is higher order. This is most significant, isn't it? What is the convention here also? Like I write 875. 875 means 5 is at unit place, 7 is at tenth place, and 8 is at hundredth place. Is it like that? This is convention. However, if you tell that why we are following like that, because first of all we have established certain fundamental rules, and then we are building up higher number, higher things on the fundamental things. Similarly, here also there is no harm to write as far as logic is concerned. You can write here M0, M7, but accordingly this weight number or term will be there. Okay, it cannot be like M2 cannot be this one. Okay, M2 cannot be written as X, Y, Z. Got it? Yes,
Yes,
I know.
sir.
Okay, thank you. So many sim. Why it is not erasing? Okay, I will look into later on. Yeah. So now coming to on this table, how to write these functions. Uh, Let me take drawing tool. Okay. So this is any arbitrary function. I do not find anything. However, you can formulate any function based on certain logic. So this is three variable input covering all 8 possible combinations, right from 0 to 7. Then F1 is defined in certain way that when this logic occurs, that is X bar, Y bar, Z, it gives 1. Another case, X, Y bar, Z bar, then also logic 1. Then last one is x, y, z. Then logic 1 comes up. Means whenever we are going to write the function f1, then we have to write like function 1 is function of x, y, z is equal to, I will write it down short form. This is what? 1 m1 comma, this is 4 m4 and last one m7. Okay, or more conveniently, simply 147. It means these are the min terms. Okay. Similarly, another function is given here, f2. So f2 is here now. I will just simply, instead of writing this, f1 is 1, sorry, f2 is 1 at the logic when x bar y z, x bar y z is written. Next, we have to look where f2 is 1, that is x y bar z, x y bar z. Next is this one, x y z bar, x y z bar. And last one, x y z. And then we can write m3, m5, m6, m7 according to this. Okay, so this is how we can write. From the truth table we can write function, and from the function we can write the truth table, or vice versa. Okay. Now coming how to convert one combination to another one. Suppose f1 is given here. I think this is f1. Let us see where it is. F1 is written here. 1, 4, 7. Three terms. F1, is it another function? I think. Now consider the complement of a Boolean function. It may be read from the truth table by forming the meters for each combination that produces 0. Yeah. If we want to write f1, so f1 complement means we have to see the output where we have to see this function f1 where it gives output as 0 instead of 1, because we are writing down complement. If we write just simply this, so we have to look wherever function gives 1. If we want to write the function in complement form, so simply from the truth table we have to look where this f1 is giving logic 0. So at this place, this place, this place, this place, this place. How many places? 1, 2, 3, 4, 5. Okay, so 5 places. So let us see whether these are 5 places or not. So 1, 2, 3, 4, 5. Okay, these are the 5 locations. What we can verify each one, no problem. Let us verify randomly one. So f1, this one. So this is what? This is x bar y z. X bar y z is there. Yeah, x bar y z is here. Okay, it means f1 complement is formed where function produces a 0. Okay, in this way we can write this f1 complement. Now, now f1 complement is nothing but the your max term. So, and better to write this in normal form, this even max term also, f1. So how to convert this thing into normal form? Of course, that will be max term representation. So let us write it one by one. X bar, y bar, z bar. Take the complement. Okay, actually complement is from outside here, entire this and this side also. So it will be the f1 double complement will give you f1, and this complement of entire function is here. So it will go inside, and this addition operation operator will change into product. Okay, so 1, 2, 3, 4. So 4 product terms are there. 1, 2, 3. So 1 is not there. So that is a typographical error. So you have to find out. Okay, this is your task. A task is given to entire class to identify a typographical mistake. Okay, why is it not moving? Okay. Are you able to see this? What I'm talking about, class?
Yes, sir.
Yes, sir.
Thank you for response.
Sir, the complement of the third term is missing.
Complement of the third term, one, two, three. It means this one.
Yes, sir, it's missing.
So, okay, very good. Thank you. This is what I want to know from your side, because that will show your presence of mind and involvement in the class. Okay, let us begin. So this is your x plus y plus z. So it is available here. This will be your x plus y bar plus z. This is available here. This will be x plus y bar plus z bar. X, it is written here x bar, so it should be x only. So this is not there. So you are right. Here let us see. This should be x bar plus y plus z bar. So this available, and x bar y bar z, x bar y bar z. This is here. It means this term is missing here. As far as, however, you see finally they have written here. Whenever they are writing, see how many terms are there? 1, 2, 3, 4, and that has been converted into subscript form, like M0, M2, M3, M5, M6. So there may be some typographical error, that M3 is not mentioned here. So can we write here? What should I write here to make it correct? Okay. Uh, yeah. So tell me, what should I write here?
X plus y
X,
bar plus z bar.
x plus y bar plus
Z bar.
z bar. Very good. So now this F1 is represented in your max term. So max term is nothing but, you see, a kind of pause product of sum. So you see these terms are expressed in sum form, SUM form. However, these are all product. So product of sum, product of sum. Okay. Similarly, F2 also can be the way F1 is represented. Similarly, we can express F2. Okay. So these are the interchange. So it will also prove like this. Mj complement is equal to M capital Mj. Okay. So this proves here. Mj complement is equal to capital Mj. Mid terms, complement of mid terms is equal to max term. Max term is formed with the help of OR, and mid term is obtained through AND operation. Okay. Now sum of mid terms. So these literals, these one by one literal, these are called mid terms. But if they are expressed in full flash this standard form, then it is called sum of mid terms or standard soft form, sum of product. Okay, these midterms are what? These midterms are and of prime or unprimed. Oh, sorry, unprimed is without bar. So prime or unprimed. Sum of midterms. Now, yeah, let us do this example carefully. This example says that express the Boolean function, that is the f, is equal to a plus b bar c as a sum of midterms. This is the question. So express a function f is equal to a plus b bar c as sum of midterms. You have to express as a sum of meters with a standard form, a canonical form. So what is the expected thing? You see, from, from after observing this function, we can see this function f is a function of variable a, b, c. Okay, sounds sensible? Because we cannot write here d because there is no indication of having variable d, but b, c, and a are there. That is why we can write here f is a function of a, b, c variable. Now we can write all these terms a plus b bar c. Is it okay? Anyone can respond, please?
Yes, sir.
Okay, thank you. Now, first look at first terminal, this a. A, this function is consists of variable a, b, c, but first literal is representing only a. It means it is the missing term b and c. B and c variables are missing in this function. So you see here in table, whenever we are writing function, any function output say f1 or f2, you see it consists of all variables, isn't it? Every f1 wherever logic 1 is there, or every f2 wherever logic 1 are there, if we want to write its function, so it consists of all three variables. Okay, so we want to know what is the status of other missing variable. This is the our expected, this that is our objective. So how to find out the missing variable without changing the logic, without changing the function itself? So the method is, this a is, we have written here left hand side. If a is multiplied by 1, if a is multiplied by 1, it will be the same function, isn't it? B is multiplied by 1 means that would be only. So anything if you multiply it by 1, you will get the same thing. Okay, and this is what is the logic here. So a is multiplied by 1, but what should be expressed in terms of missing variable? So in a, first let us see missing variable b. How to include missing variable b? By writing b plus b bar is equal to 1. Is it okay or not? Let me prove here. This is OR gate, and here b suppose 1 and b bar is equal to 0. What is the output here? Anyone?
One.
1. So it means b plus b bar is equal to 1. And this is what we are trying to do here. We multiply a into 1, but that 1 is represented by b plus b bar. And I expect, so it will be ab and ab bar. So we retrieved the one missing variable in the function from the function a, which contains literal a. Now still one more variable is missing, that is the c. Apply the same principle in this as well as in this. So ab multiplied by 1, which is represented by c plus c bar, plus this one a b bar, we are writing like that, and multiplied by 1 represented by c plus c bar. Now expand. So you will get here a b c, then a b c bar, this one, and here also similarly a b bar c, a b bar c, and this one a b bar c bar. Got it? So now you see a consists of these four mid terms. So a is now abc plus ab c bar plus a b bar c plus a b bar c bar. Sound sensible?
Excuse
Okay.
me, sir.
Yes.
Sir, in the first missing term, instead of the variable b, can we put with the variable c? Will we still get the same answer?
Yeah, because A plus B is equal to B plus A. Will you not get? Just you do. Let us do yours one. You are telling that just changing the order.
Yes, sir. Instead of B, we'll use C in the
Yeah,
first thinking.
yeah, you do that. That does not. Oh, okay. Let us do here. A, you want to multiply C plus C bar. Okay. Should I use this Jamboard? Share this tab instead.
Sir, I think we will get the same result.
Ah, yeah, but he has curiosity, or he wants to know. So let me write A plus B bar C. A plus B bar C. This is a function. Can you see this? Uh, what is called Jamboard?
Yes, sir.
Yes, sir.
Okay, thank you. So A, I want to multiply with what? That is represented by C plus B bar C. Okay. So this will be AC plus AC bar. Okay. And here also I will do same thing. Here, which term is missing?
A.
A.
A. Very good. So write down B bar C multiplied by 1 represented by A plus A bar. Okay. Now you see we got this here. Which term is missing? B. So AC multiplied by 1, which is represented by B plus B bar plus AC bar, B plus B bar, and plus here this will be A B bar C plus A bar B bar C. Is it okay? Now expand.
Yes, sir.
This will be A B C plus A B bar C plus A B C bar plus A B bar C plus A B bar C plus A bar B bar C bar. Is it okay? Now,
Yes, sir. It is right.
wherever any any midterm is coming twice, we can discard one. How can we discard one? This is the logic here. Here, 1 plus 1 is
Excuse me,
equal
sir.
to what? Yes,
The fourth term will be A, B bar, C bar.
1, 2, 3, 4. This one?
Yes,
Yeah.
sir. A,
A
B bar, C
A
bar.
B bar C bar. Yeah, thank you. Thank you. Thank you so much. So here what I'm trying to tell, conventionally if it is written that 1 plus 1 is equal to what? In algebra it is 2. But in logic 1 plus 1 is equal to 1. So never confuse. This is in logic. Suppose here I will give logic and here I will give logic 1. What will you give? What will we will get? Tell me. So this is logical operation. If this is a logical operation, again I put this what is called this symbol. This is exclusive or don't misrepresent. I was just trying to indicate it. Okay. So 1 plus 1 is equal to what? This happened only in logical operation, logical or. Okay. So that is why now see anything is there which is coming twice. So this is
Yes,
what
sir.
kind of 7. This is 101. 101 is 6. And this is what? 110. No, no. This is 5. 101. No? 101 is 5. And this is 6. 110. And this is 1004. And this is 101 is 5. This is one, sorry, 001, 1. So you see 5 is coming 2 times. So only 1 time is enough. So we can write now function as here I will write in short form as 1 4 5, 6, 7. Okay, so corresponding term you can write. So this 5 is coming two times, that is 101. We have to write, we can discard this one. Okay, so how many terms are there? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. Is it okay?
Yes, sir.
So there is no as such effect if we take first C. But again, as I told you, we go by convention. After A, B comes. Then after B, C comes. Okay. So this, the entire exercise has been done here. So B is missing now. You can see 1, 4, 5, 6, 7 is mentioned here. Okay. So we can write like this. In our Jamboard, we have completed this task. Okay. Now there is another alternate way. Through truth table also we can write f is equal to a plus b bar c. This is what we have done by multiplying with 1 represented by the missing variable. Now how can we write the same thing with truth table? Let us see. This is the truth table of f is equal to a plus b bar c. B bar c. Okay. So this is function and this is three variable number. So right, a b c, all combinations we have represented from 0 to 7. Okay, this 2 to power 3 is equal to 8. That is why 8 combinations. Now a, we have to see, we know that f is expressing 1 wherever a is there. A is equal to 1. A is equal to, oh, why it is, sometimes this behave abnormally. Let me close my video so that bandwidth can be saved. Yeah. So we have to write f is equal to 1. F is equal to 1 when a is equal to 1. So you see this is a column and we have to look where a is equal to 1. So at these four places a is equal to 1. Okay, and then we straightforward write f is equal to 1 at these four places. First task is over. Now second, b bar c. So we have to see where is the b bar c. So this is here b bar c and one more place b bar c. This is okay. So this b bar c is already covered by this a. So no need to worry about, this is already covered. Only we have to put now 1, f is equal to 1 when b bar c is there. So this is 1. This is how we can write now. After looking that, it is easy to write the expression. So you can write f is equal to a bar b bar c, a b bar c bar, a b bar c, a b c bar, a b c. Okay, got it? Any confusion or any
No,
question?
sir.
Sir, please repeat.
Please repeat. Confusion
Yes,
पूछो
sir.
यार. Repeat करने वाला मोशन तो आप रिकॉर्ड वीडियो देख लेना. Anyway, let me repeat. So earlier we found f in standard form by multiplying 1 represented by the missing variable. That is the one. Another alternative is to find out missing term or to represent this function in the standard form. Standard form means finding all missing term here. So first of all, we write, we know this, as I told you, from by looking this function, we can say this function consists of three variable, neither 2 nor 4 or so on. So that we have to confirm by looking this function. Since there's no any term of d consisting this one, So no need to consider D, and cannot with 2 also because C is also there. Okay. So with the help of 3 variables, we should write all its combination starting from 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay. And then write the function where A is equal to 1. A is equal to what? And B bar C bar. So this is B bar C bar and this is B bar C bar. Okay, one call is coming. Let me pick up. So yeah, actually our head has called. There is some meeting. So you could understand how to find out f in standard form with the help of truth table. Quite
Yes,
Yes,
sir.
easy.
sir.
Okay, thank you. Now example 2.5 is here. Express the Boolean function this f is equal to xy plus x bar z as a product of max term. Now you have to take the complement of this one. Okay. So this is the procedure. Earlier, see, in order to find out missing term, we multiplied by 1. However, in max term, we add 0. If I add a plus 0 is equal to what? This will be a only. It is not going to affect. So similarly, here how to do this distributive law. No, this was, so this is f. Let us see this x y plus x bar y. Then yeah, distributive law. Okay, okay. Distributive law. Suppose x plus yz is there. It can be represented as x plus y multiplied by x plus z. This is called distributive law. Okay. So here xy is taken as one variable. Suppose I take it as one variable and x bar z as two variables. This is one and another one is there. Now I can expand this as like this. So x plus yz is equal to here x plus y into x plus z. Similarly here xy plus x bar z, I will take xy as one thing. Then this is another one xy plus x bar multiplied. Same here again xy plus z. So this is called distributive law. And through that we can find out the missing terms. Okay. So what was that? Okay. So now it can be further expanded, this term itself. So x y plus x bar, it can be further expanded as a distributive law like this. And now this is here x plus x bar is what? X plus x bar is equal to 1. X plus x bar is equal to 1. And if we multiply 1 into this term, so same term will be there. That is why you can see x bar y is here. This has been gone. And from 4 to 3 term. First of all, we have to express this function as a product of max term. After that, yes, come. After that, we can write the missing term. First, expand it max term, means write in max term. After that, you try to get the missing term. And missing term, as I told you, if you add a plus 0 will be a, means we are not disturbing the logic. So how can we do this 0? Now 0 is represented as z plus z into z bar. This is nothing but 0. Y into y bar is nothing but 0. X into x bar, nothing but 0. But how to determine? See, in this you can see z term is missing. That is why we add 0 represented by z bar. Here we add 0 represented by y. Okay, y and y bar and so on. Sorry, I have to now go because two times people have called me. People are waiting, and finally we can represent. This is the representation of max term. So sum of sum form is represented with summation, and pos form is represented as product. That is the pi. Okay, so with this, thank you for attending this class. See you next class. Bye.
Thank you, sir.
Thank
Thank
you,
you
sir.
very much. Stop recording.